helping Hub88. So we have Nokia, of course, our host company here, and JJR Marketing, and Ice Miller Law Firm, and West Suburban Angels. So I wanted to thank our sponsors for helping us with all of our tech talks and our other programs. Just a couple of notes. We do have a summer camp, just a week left of registration. So there's information on the website, hub88.org. And we'll have another tech talk next month. I think Lori can talk about that. Our communications lab memberships are open. There's been information on the website about that as well. So that's been really exciting for companies to come in and use some advanced communications technologies that we might hear about a little bit about today. Welcome, and I'll let Lori introduce our speakers for today, but feel free to stay and ask questions, and thank you for supporting Hub88.
So welcome, everyone. Thanks so much for coming out today and supporting, as Phil said, Hub88, and also in support of FermiLab, which is really a gem here in the western suburbs. We're really fortunate to have something like that. And for so long, I remember going as a child and, wanting to see buffalo, and also just interested in what the very tall building was, because there was not a lot of tall buildings out that way. So it's just kind of interesting. But so we have, let me talk about Tech Talks. So every month, usually the third or fourth Wednesday of a month, we will have a Tech Talk. You can always find information on it at hub88.org. We will post out. We'll do social media. Let me give a nod to my friend Maya over here, who helps with social media and helps Phil. She's a NEQA student, correct? Yes, going to be a senior, and tech women in the making. So, and next month, we have an interesting, we're sort of focusing on entrepreneurs a little bit with our technology. And so please tell all your entrepreneur friends who are considering podcasting to come, because we're going to talk about all things podcasting. So, from editing software to, I don't know, stuff I don't know. So that's why I have to come myself, I guess, right? So podcasting. And then we're working really hard at getting a calendar up on the website that'll have speakers going further out. It's just a matter, we just started really working on this. So we're getting better as we go. So now I want to talk about our speakers today. So we do, as I said, have FermiLab here, and I want to start with Cherri. So Cherri, wave to the crowd. There we go. So, I didn't know what to expect when I talked to Cherri, and I was floored. She, she's graduated from Georgia Tech. She graduated from Georgia Tech, and as an engineer, civil engineer, and she built offshore platforms, like for oil, I'm assuming, oil and gas platforms. I mean, wow. And then went and got her MBA and went and became a GM in a manufacturing, I guess they were doing system integration, MES work, that sort of thing. And then joined the Department of Energy, and I may be skipping over a little bit, but joined the Department of Energy, where she oversaw the FermiLab organization. So she was like, I would say from that side, you were working with FermiLab. And then eventually she, then was an entrepreneur and of an electronic components distributor, and now has joined FermiLab. And her role really is to help find opportunities where FermiLab can do collaborative research and also license the FermiLab technology. So, she's really outreach for Fermi and kind of sales, sort of in a way for something like that. FermiLab is a part of the Department of Energy, correct? So they'll tell you more about that. And then second, we have Wenji Wu. So Wenji, born in China, wave, that's right. And he came to the U.S. in 1999, I believe you told me, and went to University of Arizona, got his master's, got his PhD, and I think, I didn't ask you, but it was computer engineering or computing engineering. And then he joined FermiLab in 2005 as a really doing, I guess, high performance networking. And that's what he's going to talk about that today is research. He's involved because Fermi is about research, you know. Cherri had said to me one thing that I thought was really interesting. And she goes, at Fermi, we have, you know, physicists or physics people who want to know stuff. And then you have engineers who then want to know what we're going to do with what we know. And so Fermi is all about, you know, learning just what's possible. So thank you so much. And I think Cherri's going to start. And you're mic'd up, right?
And I believe I'm on now. Is it working? Okay, good. Thank you. Thank you, Lori. So good evening, everybody. I really appreciate the opportunity to come and share a few words with you. I'm going to go through some very few slides. It's going to look like more than it really is, but a very few key points about how to work with a national laboratory. In doing my homework on Hub88, I know that there's a mix of Nokia people in here. Nokia people, raise your hands. There might be a few entrepreneurs in the audience. A couple raising your hands. Okay. So I'm trying to bridge both that big company and that small entrepreneurial sort of front in talking about it. And I'm actually going to talk about more than just FermiLab. So let me just, I'll start with a few words about FermiLab, who we are in case you haven't been there. We'll talk more about the little national lab system at the Department of Energy, but mostly I want to focus about how do you work with us to partner in technology and accessing our resources and know-how. See, is this thing working? There we go. So FermiLab is America's particle physics and accelerator laboratory. And as we say, we bring the world together to solve the mysteries of matter, energy, space, and time. The way I usually describe it is we build the world's largest machines to find the universe's tiniest particles. So in our pursuit of science, we do develop a lot of technology. We build and operate high-power, high-reliability accelerators. One little-known fact is when we're running our accelerator complex, we're running at a 98, 99% uptime. And there aren't too many manufacturing operations that can do that. We also deliver products to our customers. Our customers are experimenters who have very large experiments, and they're looking for data. We actually make commitments of how many protons or neutrinos or other particles we're going to deliver to our customers. So we're more like industry than industry thinks. We are the largest U.S. accelerator complex, second largest in the world. CERN is still the largest. We are on a 6,800-acre site, only about 6 miles from here. Our budget is a little over $400 million a year right now, about 1,800 full-time employees, but we also host 3,200 users from around the globe. So truly an international laboratory. And in fact, we're working on our next big project, which is Long Baseline Neutrino Facility, Deep Underground Neutrino Experiment. And I'm not going to talk about those today, but you really should visit our website to learn more about it because it's really exciting. I'll say only this. We're going to shoot a beam of neutrinos from FermiLab through the Earth to a mine in South Dakota to understand neutrinos. So in developing that science, we do technology. Obviously, accelerator technology is a big piece of it. We have the largest concentration of accelerator experts. We have a lot of unique facilities for design, test, and operation of the various components. We also do a lot in detector technology. And the easiest way to think about our detectors is they're basically microscopes or cameras for looking at the subatomic world. So we care a lot about things like 3D readout electronics, data acquisition systems. We use liquid argon as a scintillator material. We work on things called time-of-flight detectors because we need to be able to match up particles from one end of a beam to another and understand what happened. Radiation-hardened sensors, very big for the aerospace industry as for us. And again, there are some facilities available that industry can access. And finally, computing technology, which is, I think, where you're mostly interested, state-of-the-art computing facilities and expertise. We are a pioneer in managing big data, and we mean really big data, and Wenji will talk to you a bit more about that, and extensive capabilities in modeling and simulation. We are one of 17 national laboratories, so while what I'm going to describe next are the types of ways of working with a national lab. What I described for FermiLab is equally applicable to any other national lab. And all of these labs have different capabilities that are available to industry to partner either through collaborative research or for licensing technologies. So at FermiLab, there's basically 4 different ways that we work with our collaborators. Obviously, procurement is the one that most people are familiar with. We spend a lot of money. More importantly, we buy a lot of technology, and we work with a lot of small businesses who are developing new technologies that may meet our needs. So when we're building a new accelerator, we're constantly pushing the envelope of what is available in industry and having to work with our vendors to really do joint research to get their products to where we can actually use them. Strategic partnership projects is where we do work for others. Cooperative research and development agreements are where we have a mutual research interest, and then, of course, licensing agreements if we have patented technology that industry wants to commercialize. These are just a few examples of some of the people we're working with. This is an example of a procurement-related relationship. The company is called Enhanced Semiconductor, formerly called Tezeron. Some of you may be familiar with them, but they're really pushing the envelope on 3D vertically integrated circuits. We've been working with them to understand how we might use these types of chips for our advanced detectors, for both high energy physics and for what argon does in basic energy sciences or light sources. But out of that, we've also started developing some technologies that are available for licensing that would lend themselves to high-speed pattern recognition solutions or high-resolution imaging systems such as those used in the medical field. A more interesting partnership is with Ball Horticultural right in West Chicago. They actually send us seedlings, which we expose to a neutron beam on a periodic basis, which then causes interesting things to happen with these little cuttings. And out of those cuttings, they have developed new plant patents, which is a specialized form of patent. The most successful has been the Salvia Mystic Spires Blue, which you can see a photo of on this slide. And they continue to send us seedlings, which they then grow, and when something interesting develops, they patent it and commercialize it and sell it worldwide. Another agreement was actually a 3-way partnership with Northern Illinois University, Radiabeam Technologies out of Santa Monica, California. And this is working on a nanotube cathode, which is used to initiate the electron sequence in an electron gun. This is going to be important for us because we're currently working on a new accelerator concept for industrial application that requires a very short, very tiny initiation sequence in order to make a compact accelerator. So you can see here the results have been fantastic improvements in beam currents from a very tiny technology. And finally, in a sort of off the beaten path, one of our physicists came up with this idea of using electromagnetism to clean up oil spills. He has since licensed the technology from the lab and formed a company which is in the process of building the prototype, which will be tested later this summer. So we're very excited about this, that we may actually have a commercial product in the market within the next year or so through one of our partners. Another way we work with users is through user facilities. Now, FermiLab is primarily a facility for university researchers doing physics, but Argonne has several user facilities available to industry. The Advanced Photon Source is basically a super high-power microscope capability to look at very tiny structures and new materials. There's an advanced computing facility. They have some other facilities, including a Center for Nanoscale Materials. And again, you're able to access those through the Argonne Technology Transfer and User Facility offices. Finally, the Department of Energy has a number of other resources we make available to innovators, small businesses, including the Small Business Innovative Research Program, which is a program that all agencies actually fund and support. The Department of Energy also has something called the Technology Commercialization Fund, where they will fund the laboratory half of a collaboration if the industrial partner is willing to contribute half of the effort to do some joint research. There are public-private consortia through the Office of Energy Research or Energy Efficiency, Latin Energy Innovation, Energy Materials Network. And then finally, a new sort of direction for the labs are these innovation centers that are associated with 4 of the national labs, one of which is at Argonne, which is called Chain Reaction Innovations. This is where an entrepreneur who has their own technology can actually apply for funding and access to the national laboratory to develop your technology. So you can actually get funded for up to a couple of years as you're trying to get a new technology developed to the point that you can attract investment capital. So if you haven't checked out Chain Reaction Innovations over at Argonne, for the entrepreneurs in the crowd, you might want to visit their website and learn more about it. These last few slides, and you're going to have these slides, so I'm not going to cover them in detail, are just a series of websites where you can learn more about all of these things I've touched on. Our own website is where you can find the FermiLab technologies that are available for license. The Department of Energy has a new site called the Lab Partnering Service at labpartnering.org. Here you can actually enter a particular topic that you need assistance with, and you can search through all of the laboratories to see what might be available or who you might want to talk to. There's even a number of researchers covered on the site on specific topics to help you zero in on who you might want to chat with about potential collaboration. There's also a site where all of our patents are housed, and it can be searched through this kind of device, which is looking, so if you're looking for sensing and detecting or monitoring technologies, you can dive through the entire Department of Energy patent portfolio, which is thousands and thousands of patents, and get to what you're looking for a little more quickly. Federallabs.org covers all of the government's laboratories, not just the Department of Energy, but every agency that has a laboratory, and there are quite a few in the Chicagoland area that you could also collaborate with because they also can work with industry. So there's a wealth of other resources here. And finally, for those of you who are just looking for some funding opportunities, FBO.gov is the place to go to look for who has grant money, contract money, who might be looking for partners to pursue new innovative frontiers. So that is, oops. Finally, if you don't like websites, there are people. These are the people at FermiLab, and we can maybe help you navigate all of this wealth of information to get you where you want to go. With that, I'm going to turn it over to Wenji and let him take it away. Oh, no.
Good evening, and thanks for inviting me to be here. I'm Wenji from FermiLab. My talk is Advanced Network Research at FermiLab. This is cover my work. I joined FermiLab since 2005, so this is the work and the cover the last 10 years research work and some of my colleagues' work. Here's the agenda. First, I will talk about why do we need advanced network research at the FermiLab. Then I will discuss about the advanced network facility at the FermiLab. Finally, I will talk about the major research projects, and we work at the FermiLab. And due to the time constraint, I will focus on 3 research projects. That's wirecap and network traffic analysis using GPUs, and finally talk about the quantum network research. That's a new area for us. Why do we need the advanced network research at FermiLab? Because FermiLab hosts and participate several large-scale scientific experiments and international collaborations. Each such experiment generate a significant amount of the data, and this data need to be analyzed and for scientific discoveries. So we need the ability to transfer the data quickly around the world. So there are several experiments. You can see there. Can you see here? You see the CMX experiment. This experiment is now actually carried out in the CERN, and every year there are dozens of petabyte data need to transfer from CERN to FermiLab, then from FermiLab further to U.S. University and research laboratories for further analysis. And that's the Nuon experiment, and this is LBNE and the DUE experiment hosted at FermiLab. And the FermiLab has long engaged in network R&D in support of the missions. We have a 100 gig network connected to local, national, and international wide area networks. And there's now talk about the advanced network facility at FermiLab. FermiLab has invested heavily in its network infrastructure. So we have the advanced network facility. The first picture shows the Fermi wide area network facilities. You will see there are two board routers. There are two board routers and connect the FermiLab to the external networks, and both has 100 gig network connectivities. And then you will see that the left one is the production network, and the orange one is the testbed network. And we separated the production network and the testbed network and to avoid interfere with each other. This diagram shows the Chicago Express network. It illustrates how the Fermi and the Argon and the Starlight L3POP are connected with each other in the Chicago areas. That diagram shows the cross-Pacific SDN testbed. That's the SDN testbed between FermiLab and South Korea. So the SDN technology allows us to program network at runtime to suit the application requirement. So that's the new testbed we built for the DOE research project. This diagram is a proposed quantum network testbed, and we just submit a proposal to the DOE to build up a quantum network testbed in Chicago area. If the project were funded, then we can carry out some high-impact quantum network research in this testbed. Now I talk about the major network research project at FermiLab, and first talk about WireCap. WireCap actually is we develop a novel packet capture engine for commodity NIC in high-speed networks. So packet capture engine is a critical cybersecurity tools, and before we need to before we analyze the traffic, we need to capture the packets from network. So and in high-speed network and capture network without loss is challenging. So for this project, we developed the WireCap and to do the zero lossless packet capturing. And then the next talk about the network traffic analysis using GPUs. And we have been working on this project since 2013, and we developed a GPU libraries to do the packet analysis. And the third one is the quantum network research, and that's the new areas. FermiLab, that's the new areas. FermiLab has a new, exciting, and promising quantum research programs. And last year, we received 10 million grants to carry out the quantum science research. And then the Big Data Express project, this is a DOE-funded research project. for this project, and we deliver high performance and schedulable and predictable data transfer services. And for the idea for Big Data Express is develop the resource orchestrators to integrate the systems and storage and networking in the end-to-end data transfer loop to optimize data transfer. For this project, and it's well received, and currently this project is developed, deploy and multiple major data centers in the world. And the MDTM project is also a DOE-funded research project. And the idea for this project, we're using the multi-core technologies to accelerate data transfer on the multi-core systems. So for this project, we develop a data transfer tool called MDTM FTP. So now this tool is widely used in the major data centers in the world. So now I talk about the WireCap, and we have been working on this project since the 2013, and the major contributor is me and also my colleague Phil. Packet capture, that he first talk about some basic of packet capture engines, and it capture incoming packets and network data for analysis. So it will handle a continuous flow of packets. It's used by the cybersecurity and the applications and the traffic characterization applications. There are different type of the packet capture engines. So some vendors and deliver the packet capture engine in the ASIC and the FPGAs. The ASIC and the FPGAs are hardware-based packet capture engines. So typically they are expensive and lacks the flexible. And due to this reason, some researchers start to develop the software-based packet capture engines, and they're using the commodity off-the-shelf NICs and to do the packet captures and using software drivers. And here is how the commodity off-the-shelf packet capture engine works. So when the packet interfaces, here's the architecture. And when the network traffic comes and the network interface receives the packets, so then packet is removed to the there is a receive ring buffer. Here is the receive ring buffer. Then the packet capture engine provides mechanisms to deliver the packets from the systems to the user space. So that's how the generic capture engine works. For the capture engines, and is a critical performance metric is you don't want to see the packet drops, because if you suffering the packet drops, and it will degrade the application performance and hurt the application integrities. So that's the performance metrics. So what is WireCap? WireCap is an innovative packet capture engine, and it's designed for the lossless packet capturing for commodity NICs in high-speed networks. And the advantage of the WireCap is cost-effective and flexible, because software-based solution is flexible, and it's intended for multi-core systems with multi-queue NICs. For the WireCap, there are two advanced mechanisms for lossless packet capturing. So we have two advanced mechanisms. One is called ring buffer tool mechanisms, and the ring buffer tool mechanism that's for short-term traffic burstiness and avoid the traffic loss for the short-term traffic burstiness. Another is called body group mechanism that's designed for the long-term traffic floodings. So these two mechanisms to avoid the to achieve the lossless packet capturing. So here is the high-level architecture you will see, and for that's computer systems. And if you have the NIC cards, for the NIC card, there's multiple queues. If you see the multiple queues, and for each each queues, there is a receive rings. So when the network traffic is coming and the traffic is distributed to receive rings, then the wirecap mechanisms deliver the traffic from the receive rings to user space. And here is each receive ring is mapped to a particular course. And here is the wirecap ring buffer pool mechanism. The ring buffer pool mechanism is provide sufficient buffering at NIC receive ring level to accommodate short-term burst of the packets. It eliminates the packet loss from the receiving overruns, because when the traffic, in the networks, if there are bursts of traffic, and it can easily overrun your packet the engines. So with the ring buffer pool mechanisms, and we can handle the short-term burst of packets. And also we have the mechanism to minimize the packet capture overheads on the systems. And it has dynamic and continuous packet buffering mechanisms to provide continuous enough space to hold the incoming packets. So here the key mechanism is buffer chunks, the key innovations in ring buffer mechanisms. So I will talk about details about that. And the wirecap body group mechanisms is designed to handle the long-term traffic burstiness, because in the multi-core systems, and each receive ring is mapped to a particular course, and each receive ring for a particular core. But if there's long-term traffic imbalance, and all the traffic go to a particular core, and the core cannot handle the traffic in time, so that particular core can be overrun. So the body group mechanisms, it group up a couple of multiple CPU cores to form a body group. So if there's a traffic imbalance, the body group mechanisms will offload some of the traffic to the less busy cores to avoid the particular core be overrun, to avoid the packet drops. And there are some miscellaneous and about the wirecap. Here's the project website, and we have the paper. The paper is published in the IMC14, and you can go to the website, get the paper for the technical details. And the wirecap technology is patented, and we filed the patent application in 2015, and the patent issued in 2018. And the software about wirecap is issued to multiple agencies, including the U.S. Army Research Laboratory, and the Navy Research Laboratory, and the Air Force Research Laboratories, and also the Los Alamos National Lab. Now talk about the network traffic analysis using the GPUs. This is my work and my colleagues' work. And first, I give some basic about what is the network traffic analysis. And network traffic analysis is indispensable for the cybersecurity, the network operation and the management. For when you run the network, you want to see what traffic flow in your network and what type of applications runs in your network. And also for the performance troubleshooting. For the performance troubleshooting, if you run the data transfer, you will see the TCP, and we can capture the traffic and see what's the TCP congest window, what's the congest window size, and what's the receive window size. So it helped for the performance troubleshooting. And also it's a network traffic, and it's critical for the network security. It's an important cybersecurity tool. typically, network and traffic analysis system is sit at the network borders, so it scrutinizes the traffic, inbound, outbound traffic. So here is, and it performs the basic functions like the profile the traffic activities and also scan the traffic content for suspicions and pattern signatures. So this is usually called the deep packet inspections, it's DPIs. And here, network traffic analysis is challenging. The challenge arises from two aspects. The first aspect is the high performance network. In high-speed network and like 100 gig network, every second it generates millions of packets and are generated and transmitted. If you want to analyze such amount of the packets, and it needs a significant amount of I/O computing power and I/O throughputs. The second aspect is arise from it requires a complex packet analysis algorithms. Because the algorithms now are increasingly complex as security threats become more sophisticated. So because of that, we need a flexible and programmable computing platforms. So that's two reasons and why the network traffic analysis is challenges. So because of the challenges, so why we why we use the CPU as the solutions. We compare the CPU. There are a couple of the computing platforms like the CPU. The CPU is generic computing platform, or the NPU ASIC. NPU ASIC, that's the particular customized the computing platforms. So compare with the other computing platform, the GPUs, and the first GPU has high computing power. Typically, GPU has order of magnitude the computing power than the CPUs. For the ASIC and the NPUs, it varies because some of the ASIC platform can have high computing power, but some may not. But that varies. But for the GPU has the different type of the I/O structure, so it has the much higher memory bandwidth than the CPUs, and also for the ASIC because this is customizable, so that the performance their memory bandwidth is variable. But for the ASIC NPU, typically because they're customized a specific architecture, so this is more expensive. And also for the GPU is easy to program. CPU, we know CPU is easy to program. CPU, you have so many compiler and different programming languages. But the ASIC and NPU is difficult to program. For the GPU, because like the NVIDIA, the CUDA or that platform is rolled out in 2008. So GPU is easy to program. And the last and the GPU has the data parallel execution model. For GPU, it has like NVIDIA GPU, it has thousands of cores. So for the network processing, and you will see there's millions of packets. So there's a lot of packets in your network. So there are a lot of data parallelisms. So the GPU, the computing model, because it's high throughput computing. So this model fit with the data parallel execution model fit the network environment very well. For CPU is high for the high speed, high performance computing for serious computing. So CPU is work pretty well. But CPU, the multi-core technology give the CPU has dozens of cores, but dozens of cores still compare with the GPU is not enough. But the NPU and the ASIC, they don't have the data parallel execution model. So this computing model does not fit the network environment very well. And here is our GPU-based network traffic and analysis framework. And here's the framework you will see. Here is the you will see that network traffic source, and we can do the online analysis or offline analysis. If we do the online analysis, we're using the wirecap to capture network traffic online, then move the data into the GPU domains. Or if we have to do the offline analysis, we have the storage, and we're using the libcap libraries to reading the data and from the storage and into the GPU domain to do the analysis. In the GPU domain, we do two types of analysis. First is do the header analysis and or do the payload analysis. So then we support our framework support multiple type of applications. We do the network monitoring. So you run this one, you will see who is sending most, who is receive most traffic, and who has the big traffic flows. So we do, and the TCP has how much traffic is go through TCP, how much traffic go to UDP. So that's network monitoring. For the IDS, because now we have the library can do the payload analysis. We can scrutinize the payload and do the particular traffic signature patterns, and we can perform the deep packet inspection or traffic engineering, because in our environment we're looking for the high impact flows and high throughput flows, because we have element flows. So once our application detect there's high impact flows and the elephant flows, we can use SDN technology to steal the traffic and bypass the traffic through through the border routers or the firewalls. For example, if we look at this diagram, and this is our this is our production network, and once we see this is our firewall systems. So we do a lot of data transfer between FermiLab and the CERNs. Once we detect the high impact traffic, then we can we know it's the scientific data flow, and then once we detect that traffic flows, then we using SDN technologies can steal the traffic, bypass the firewall systems to get better performance. So and there are some other applications. Currently, we have the network monitoring capability, IPS capability, and the traffic engineering capabilities. And we've been working on these projects since 2013. So we already developed a GPU accelerated library for network traffic analysis. There, it consists of dozens of the CUDA kernels, and these kernels can be combined in a variety of ways to perform intended analysis. There are two types of GPU analysis. First is header analysis. Header analysis is pretty easy. The difficult part is packet payload analysis, especially for the TCP streams. For the TCP streams, and we have new advanced mechanisms to do the TCP string assembly in the GPU domain. All the reassemble the TCP flows in the GPU domain and to match the signature patterns across packets. Because if you have the traffic some particular patterns, a signature across multiple patterns, you need to reassemble, and then we have the capability to do that now. And here is the related publication and the talks, and that's the GNetMon and the Wirecap. That's the related capturing capability. And we give the talk about our work in the GTC 13, 14, and the 17. I missed the 13 talk. And the Golden Eye, that's the recent work, and this part covers how we using the GPU to reassemble the TCP flows and to do the signature pattern matching. So this is the most recent work. The future direction is we will, for the network traffic analysis using GPU, we will continue to mature our packet processing framework to deliver multi-layer defense solutions. And then we will, for our framework, we try to add the machine learning and AI technologies and to automate the detection and the defense of zero-day attacks. So the next step is adding the AI components to the framework. Now I talk about our quantum network research. So quantum network research is new areas, and FermiLab has an exciting and promising quantum science program. It's led by Penaltius, and this is a project website. So last year we received more than $10 million grant to carry out research in the quantum science, and including the quantum network research. For the quantum network research, and recently we submitted a proposal to the DOE OSCAR program, and the proposal is called Illinois Express Quantum Network Testbed. So it's the FermiLab, and along with Caltech, Northwestern Universities, and Oregon National Lab. So this project, and the proposed Illinois Express Quantum Network is a metropolitan scale quantum network testbed, demonstrate the important advanced quantum network capabilities. Here is the network, and you will see here is at the Fermi side. You will see this. This is at the Fermi side. We have the couple of the Q nodes we call the quantum nodes, and that's like our computer nodes. That's Q nodes. And here is the all optical switch, and this is EPS. This is entangled photon source, and this is a Fermi side. We call the quantum lane, and here is also have the quantum node at argon. So this is connect to the dark fibers between. Actually, this part is currently we already have a FQNet called is a step between Fermi and argon. It's FQNet. It's currently in operation. So we can carry out some basic research on this part. Because for this project, we will enhance the Fermi QNet and to call it a Q lens. Then this component, this part is in the northwestern, and northwestern that's the starlight. So we will put the old optical switch here, and then put the EPS and the entangle the photon source here, and connect to the northwestern in eastern. This part is located in the Chicago, and this is at eastern. So they connect by the dark fibers. So this whole thing is we call the Illinois quantum testbed. And the key feature we will do is you will see there are multiple nodes and multiple Q nodes, and the support of multiple nodes is flexible, and we have two EPS. So one EPS at the Starlight at Chicago, another is at the Fermi. So we have flexible and a resilient network configuration. So even one EPS is malfunction or die, we have other options. Then we support multiple users, and because we have multiple nodes, and we can support multiple users in this testbed simultaneously. And the key part is the coexist with the traditional network in the same optical transmission systems, because these all fibers, because some researcher and they using a satellite to do the quantum communications. And the reason DOE funded all the quantum projects, the plan to fund all the quantum projects in the traditional fiber systems. So it required the coexist with a traditional network in the same optical transmission systems with same DWDM technologies to reduce the cost. And here for this project, we will adopt a layered architecture. So the first layer is quantum layer. The next layer is the physical layer. Physical layer is quantum physical layer. The next layer is the optical path layer. Then it goes to the entanglement distribution service layer. So we have layer architecture. And also we have centralized control, because you will see here is all optical routers, and we will using the SDN technologies and control the network. So we have centralized control to control these networks. So this is the new areas, and it's pretty exciting. If this project get funded, we can carry out some high impact research in the test bed. So questions? Yeah.
Thank you.
Yeah.
I saw Ian, your hand up, so I'll let you start with questions.
Okay, thank you.
Yeah.
I have a couple of questions.
Yeah.
First, a simple one. The quantum network project that you have, is that with AT&T as well, as a partner?
We trying to get involved AT&T. That's what I heard, but
Right.
Oh, sure.
AT&T is actually partnered with Caltech, so yes, they are involved.
Okay, it's through the Caltech partnership. Okay.
Caltech is our window to AT&T.
Okay. I saw some information that one of the AT&T VPs had visited Fermi last year.
Yeah.
Okay. Another question is your quantum network research. Does that include encryption, and also are you doing anything in quantum computing, which is not the same thing, but
No, because the quantum communication and the quantum network, you can do some real work at this stage.
right.
For quantum computation, and there's a lot of simulation and for the quantum communications. And the IBM quantum computers, you can do some work there. But that part work has not connected to the combined with the quantum network part, because under the interface with the quantum computation and the quantum network is still a big gap. Because for the quantum technology and the quantum the processor is fine. We can have the IBM has some processor in their system, but the quantum memory part is an issue. So for this test bed and the first step, we will do teleportation and integrament function source, the pair distribution. So that's the major focus. And also we will do the DV/CV part of the conversions. That's a plan.
But let me address the non-network stuff. We do have other research in support of quantum. One of the areas is actually developing quantum qubits that will actually have a longer coherence time using some of the technology we developed for accelerators. So that's one avenue, which is an hardware related. And then actually, as far as quantum computing, we do have a partnership with IBM through Oak Ridge National Laboratory. And we are doing some work with Lockheed as well with their platform. But we're actually more the alpha user, meaning we're looking to see if physics problems are the kinds of problems that quantum computing can actually address better than high-performance computing. So we're more the user than we are the actual developer of the quantum computing structures. So.
Okay. One last question. Since you're part of a network, national network, I saw that Argonne National Laboratory, the Department of Energy had announced recently that the XLab Innovation Summit at Argonne in October will cover artificial intelligence. So are you involved, is Fermi involved in this as well?
Yes.
Okay. Okay, good.
The XLabs are a series of summits that the Department of Energy is hosting. And the idea is that not enough of U.S. industry is even aware of what we're doing. We're probably better known internationally than we are in our own country, a lot of us. And so the idea is to create these venues where we can have conversations, and more importantly, where multiple laboratories are in one place. Each laboratory has conversations like this, but we're trying to get better at representing the whole complex. So the XLab Summit will have probably almost every laboratory will have a booth or a presence there. And then they're bringing in a huge cross-section of industry to interact with them and talk about different AI topics. The agenda is still under development. XLab is by invitation only. It's run out of the Department of Energy. Yes, we're supporting it, both Argonne and FermiLab. But I would suggest, I mean, if you're interested, I can probably get your name forwarded to the inviters, but I can't guarantee how the list is going to ultimately get constructed. I do know they're looking for a very large audience for this one, so they may open this one up more.
Okay.
Some of the others were a little more limited. This one might be a little more open.
Okay, that's great. And you're still working on the agenda?
Yeah.
Okay. Okay, thank you.
Anyone else?
So I'll probably give the microphone right back to you, but kind of following up on Ann's question, is there, my perception at least of FermiLab is it's much more theoretical physics research, and Argonne's maybe a little more applied physics. Is there a lab, and that's my own characterization, is there a lab, national lab that's more focused on AI and machine learning? I know all of them are dabbling in it, but is there a focus?
That part, the Argonne National Lab, Oak Ridge has more focus on the AI part. As
Oak
far as I
Ridge,
know.
Sandia,
Yeah,
and I
Oak Ridge.
think it's Berkeley are probably relatively strong.
Because DOE recently granted the 20 million AI projects. The 20 million is 13 million goes to the energy part, and the 7 million goes to the pure AI research. 7 million, 5 million goes to the big data part, and to work with the supercomputers and those things, and 2 million goes to the basic AI, quantify the uncertainty and quantify the AI, some quantify the AI effect, some basic software part. So totally 20 million. I think it's major, the Cherri said, Oak Ridge, Berkeley.
Sandia. Sandia is the engineering lab for NNSA. So out of all the national labs, the work that Sandia does is probably the most applied and the most closely relevant to an industrial application. So Sandia typically will be working with developments that may find their way to market a little sooner than some of the other laboratories. But you're right, FermiLab is basic science. You know, our mission is discovery science, but we do develop a lot of technology all the way to production quantities. Argonne is what we call a multi-program laboratory. They actually do basic science, but they also do applied research in the energy field. They have the advanced battery research going on there. They have a new manufacturing technology center on the campus. They do a lot of, they do high performance computing, whereas we do the big data management. They're more the high performance computing guys. All the labs do simulation and modeling. All of the labs use machine learning for one application or another. So it depends on how you define it, you know, and what you're looking for. So you'd have to get a little more specific about your specific interests, and we could probably help route you to the right laboratory.
Potential for partnership with one of the labs on AI.
Oh, yeah.
For AI, the one big criteria is you need the data. So they look at the applications has huge amount of data. So that's why all the big money goes to the Berkeley or Oak Ridge.
I mean, if you're in the field, you know that AI has been around for a very long time, and industry has actually been pushing the envelope, but it's been limited by some of these other things that are just now catching up. So that's kind of where I think the lab play is right now, is trying to marry what has limited AI with what we have been able to bring to the party for other things, and maybe make that next big breakthrough in it.
Anyone else? So, Cherri, is there anything in particular you think we should ask that we're not asking?
No, you actually surprised me by asking more than I expected.
There you go. Yeah, it's a bright bunch. So, well, thank you so much again, and thank you everyone for coming
Let me make
out.
one last comment.
Oh, okay, go.
The last comment is this. FermiLab is the last truly open lab. You are able to come on site. There are public areas. We invite you to come on anytime and visit the public areas where you can learn more about the research that's going on. The big tall building you mentioned, Wilson Hall. We do still have Saturday morning physics for the young folks, so if you've got kids and you keep track of that. We've got a great YouTube site with great videos by one of our scientists who does a wonderful job. In fact, his latest video actually trended in the top 25 this week. Yeah, talking about physics.
What was the topic?
You know, I haven't seen it yet, but it's about physics, and you know, people are excited, and you know, and I do think the Big Bang Theory had a lot to do with making us a little more accessible. I was actually kind of sad this show went off the air because now I don't know how to talk about, you know, who I work with. I work with a bunch of Sheldons. But anyway, you know, we do invite people to come out and take advantage of all we have to offer at the lab. So, you know, a lot of public areas, a lot of opportunities, science, the arts, and the marriage of those two very interesting things.
That's great. And this particular, you know, we're taping. It'll be up on the website, so you can go back to it. And I think, you know, even related to July 24th, which is our next topic on podcast, when you're talking about the YouTubes, I think the thing that I just want to mention is no matter what, if you're a business, podcasts are a way to become thought leaders. And that was interesting because that's what they're doing when you put them up on YouTube, and you do that with podcasts too. So in any case, that's it for today. Does anyone have any other questions at all? Otherwise, I'll let you get on with your evening and enjoy the warm weather. Who knows how long it'll last? And dry, exactly. Thank you.